Welcome back to step 3 of the SDL for Kids tutorial. In step 3, we're going to move into the planning stage of an SDL. In step 1 and 2, we covered how to create colors and measure colors, and now we're going to figure out how to experiment and choose the next best color to run through our system. Okay, let's take a look at our task today. So in this tutorial on planning, we're going to look at the random strategy of selecting colors, the grid strategy, and then finally the statistically most efficient strategy, which is Bayesian optimization. So section 1, strategy, random. Random is basically like throwing dice. For example, if you have a dice with 6 sides and you throw it on the floor, well, you're going to get a number between 1 and 6, and they're all going to have the same probability. The same way with our RGB code, we're going to basically have 3 different dice, and they have 256 sides. So they each have a number between 0 and 255. And so we throw them all at the same time, then we write down the numbers we see on the sides, and then we just put the color on our screen. So we're just randomly choosing colors, and we hope that some of those are going to be close to our target color. And just remember, our computer doesn't know the target color, so it's going to just throw a whole bunch of die until it finds a color that is quite close. So here we have our generate random color function from step 1, and then also our calculate error function. And then here again, we also have a function that will generate colors and put them on the screen. So we have a loop that will iterate for 50 times. It will get a random color, put it on the screen, and then add the arrow to our arrow list. Okay, I can just run it here and we see what happens. Oh, you gotta make sure that you run the first cell here. And so I'll run this again. And here we see 15 colors, so a bit of a disco again. And some of those colors are closer to red and some of those are further away. So let's analyze and interpret this data. And we see here that the first color had about an error of 250, and then at step 38 around there we found the best color that was quite close to the red color. So we can actually look at that again. Probably just make a cut here. Okay, so this is the random strategy, and it is not a bad strategy after all, but it's not the most efficient one. And sometimes people prefer to do some more structured strategy. So in the grid strategy, in section 2, we kind of split up all possibilities in even chunks. So for example, if you have 3 pizzas and you want to figure out the best time in the oven, so is it 5, 10 or 15 minutes, then you just put them each in the oven and then you give it a try, a taste try at the end. And then maybe you figure out that, you know, the 10-minute pizza is better than the 5-minute one. But of course, then you don't know what happens at 12 or 13 minutes, so this is a disadvantage. So just to give it a try and get a feeling for it, we're going to use a grid step of 3 for our case. Practically, that looks like this. So our first experiment, or the first color we want to test, is 0, 0, 0. And then we're going to split up blue into 127.5 and 255. So we will split blue into 3 even parts, and then we will put all possible combinations together. So in the case of 3 colors, RGB, and a grid step of 3, that means we have 3 times 3 times 3 experiments. So that's 27 experiments. We can just take our loop from before, and this time we're going to loop over the grid combinations, and otherwise we keep everything the same. So I run this here, and we're gonna, as always, evaluate our errors. And we see here that again we have an improvement over time, and there's also some structure naturally in this process. But of course, as I said before, if your pizza is actually ideal at 12 minutes, we're gonna miss out on that. So that is where section 3 comes into the game, which is Bayesian optimization. So Bayesian optimization does require some background in statistics, and if you don't understand this straight up, this is no problem. You can look at the code in detail and do some more reading, but I'm going to try to explain it to you in the best way possible for the SDL for kids. So in Bayesian optimization, we are building a statistical model from all historical data points we collected. So if we have run some experiments, then we know that some variables will be better than other ones. And so from those variables, we can create a statistical model where we can predict which experiment is going to be the next most informative one. So which one is quite promising to create a color that is close to red. So here's the code for that. We're going to use the BowTorch package, and we will define a function called calculate candidate. So we give it the history, and then as a result, it will give us a candidate that we can now try and see how good that prediction was as a color that is going to be close to red. So let's run it here. And again, it's the same loop, except we go for 25 iterations, and instead of asking for a random color or color from a grid combination, we're going to ask for a candidate. So that is the function here. We give it the samples. We of course keep the historical samples, and then we're going to calculate a candidate and send that through the loop again. Okay, so that's not too bad. We see quite a natural progression here. We can also look at the error plot, and we see that, you know, quite steadily over time we reduce the error, and in fact we get quite close to the absolute ideal point. Some of those experiments are still off because not all predictions are perfect, but overall we do get quite a good conversions already in less than 15 points. Here is also an extra plot that I made, and this one shows you actually on top of the error curve also the 3 colors that we are experimenting with. And so you see here quite nicely how in the beginning the Bayesian optimization algorithm first thinks that it probably needs a bunch of blue and a bunch of green, but then realizes that red is probably the color that gets us closest to our goal color, which is obviously red. But the computer doesn't know that, but as it's getting the error values, it gets a feeling for which colors it needs to put into the mix. And so then it's still trying a bit of green and it's still trying a bit of blue, but ultimately realizes that green and blue are not necessary to get close to the goal, and all we need is red at 255. Okay, so as you noticed, all of these cells were actually run without the microbit, but now as a final step, because we prepared it in step 2 to measure with the microbit, we're gonna get the microbit back involved. So make sure that step 2 is working for you in the previous tutorial, and so these cells now should work for you relatively flawlessly. So make sure you got it connected and programmed, make sure the name here is the right name. Here's the characterize function again. This is just copied over from step 2. Now we're gonna check it, and here again, we got the measurements coming from the microbit. Okay. So let's load up again, calculate candidate, and now I'm gonna make sure that I'm holding the microbit against the screen so I can do the measurements. Okay, let's see. Just holding it here. Alright, so it's doing its thinking, it's building a statistical model, and then it's taking its measurements that we see here in the bottom right. And we're slowly seeing how it's getting into a more of a red tone, and then it's slowly converging to the right color. So here already at around iteration 30, 35, we see it getting quite close to the red color. We're just gonna have it finish here. Yeah, doing 50 iterations, and then we can evaluate the error function. Looks like this. So it seems to have made up its mind quite a bit already around iteration 30. And again, here's also the advanced plot. So we can see again here how in the beginning it doesn't have a good idea of what colors to put into the mix. But then as it goes along around step 20, it's basically identified red as the key component to succeed and optimize the problem. Okay, so congratulations. This is already the end of the 3-step tutorial. In the first one, we looked at synthesis, so generating the material, which is the color on our screen. And then step 2, we looked at how to measure it with a real hardware component, which is quite nice. And then step 3, we looked at planning. So what is different, strategies, random, a grid, and then finally, the best one, basically Bayesian optimization and getting that running. And all of that we did in these 3 steps together. Now you can move on to step 4, where we've prepared a notebook once more. And that one has all 3 steps in one notebook, so you can easily just run through and get a nice, fast result. All right, I'll see you there.